Some of you will recognize this as a WPC PowerDriver board, and in particular this is where the 7812 12-volt regulator is, and C2, a 100 microfarad cap. This is becoming a problem more and more, or what is becoming a problem more and more, is that cap C2 leaks like this one did. And the bottom of this doesn't look too bad, but you can see that it corroded the traces here, and it's corroded the 7812. It's jumped down here underneath the solder mask. Strange how that does that, but it does do that. It has corroded all of these components in the zero cross circuit, and it's jumped down and corroded U1, and there's a little bit here on U2 also. These are 74 LS 374s. And pin 1 of these devices is the blanking signal. It comes from the CPU board. So if that signal is not getting to U1, etc. down the line, then nothing on this board is going to work. This is the GI 374, and then each of these controls 8 solenoids as you go down the line until you eventually get to the lamp matrix. So right here, there's a black speck. It's kind of tough to see, even though I'm zoomed in. But that is the beginning of corrosion that has invaded the solder mask, and if left unattended, eventually would sever that signal, which looks like it goes to the other side of this 374. So let's get to it. I'm going to remove all these parts. I'm going to remove these 2 parts. I'm going to remove this 7812. I'm going to sand to bare copper. I'm going to conformal coat, and then we're going to put some fresh parts in. We get a socket at U1 and U2, and we'll be back. So here we are finally to the bench with this corroded WPC -3 PowerDriver board, and you can see that I've replaced all of the components to the left of the 7812. The 7812 itself, there's a diode and a ceramic capacitor behind there. I replaced that also. And I've gotten sanded down to the bare copper, and I think I'll roll in a picture of that, and then rebuild some traces as necessary. They were really eaten up, so it was kind of difficult to make it very pretty, but it is what it is. I had to take out both of these LS 374s to make sure there was no corrosion below them, and there was a little bit that connected pin 1 to pin 1 for these 2 LS 374s, and of course they were a little corroded, so I replaced them. There's a jumper. You can kind of see the blue wire that connects pin 1 to pin 1. Also replaced the headers all the way around, GI and power input and output. Installed a 1N 5401 blocking diode at the base of R223, I believe that is. And that is, the purpose of that is to protect C11, and C11 on this board was damaged. I replaced C5, C2, C4, and I think that's it on the tag. So we are in test now with one of my spare MPU boards, and we can go to the tests and get to the things that the driver board drives. And I'll make this run. Sorry, the word escaped me for a second. And this DMD test ROM, or WPC DMD test ROM, walks through all 16 of the solenoids, and then it will do the 12 generally flasher circuits. I missed one, so I had to go through it twice there. I blinked while it was going on. Let's check the GI. Usually if there's a failure in the GI, it's because somebody's been working on BR2, and they severed the trace that goes over to the zero cross circuit. So we can check the flashers and the lamps, controlled lamps, both at the same time, and that's working perfectly now. So that is it. This driver board is good to go now. Not much more to say about it. Oh, it's delivering 5.09 volts. You can see at the top, 11.7 is the regulated 12, 14.9 is the unregulated 12, 21 or so is the flash lamps, and at 73.45 is the coil power. So thank you so much for sending it. I'm gonna get it right back in the mail to you.